Our next guest needs no introduction, and so there will be no introduction given. No, Emily Riederer is a senior analytics manager at Capital One. All around amazing person, writes amazing code, does amazing not performances, presentations, and in this presentation, she's going to be talking about Convo, which is a new package that she's put together. And so very much looking forward to this one, Emily. Thank you very much.
Thank you. Very happy to be here. Let me get my screen share going here. Are you able to? Oh,
yeah, I've got your Google Doc talk title, column names as contracts. Is that what we're meant to be?
All right. So thank you, everyone. Today I'm here to talk about how we can use column names in our data set to embed important types of metadata that can help us be more confident in our kind of overall data pipelines and our wrangling methods. But before we talk about data at all, and before we talk about column names at all, first I want to ask you to briefly think about a user interface. User interfaces use a lot of very helpful visual clues to help make sure users do the right thing. For example, they'll use universal symbols, such as a floppy disk, assuming you're old enough to know what that is, to note things like what means save versus what means delete. We also have grouping of like things together, so users encounter similar or related functionalities at the same time, and aesthetics like colors to prevent us from doing stupid or careless things that we really shouldn't. And I think there's a good analogy here in the way that user interfaces encode intent, context, and warnings. Because in reality, column names are really like the user interface of our data sets, where the data itself is that functionality. However, often there's not that same tight link and the sense of design in the column names we choose. And you might argue with that, well, data's static. What sort of functionality is there that we really need to encode? But there's actually a lot if you think about it. And subtle design choices in different ways that our data act really challenge both the initial analysis producibility and reproducibility of results. For example, when we're going through any sort of analysis, it's very important to keep in mind the origin of every single field, its provenance, when and how that gets loaded, and the encodings, having very clear and crisp definitions of each field, knowing if indicator variables are 0 and 1, which condition is actually that one condition, how nulls are handled, and various features about the usage, avoiding common mistakes like feature leakage or just treating variable in a way that it really didn't deserve and it really isn't designed for. And we know that these sorts of design issues have very clear results by just a quick search on Retraction Watch can really unearth situations where all of these issues have come into play. I've just highlighted a few examples here of indicator variables where precisely the opposite outcome can be modeled and trained for, or ambiguous metric definitions have thoroughly changed and confounded the results of an analysis. So there really is a lot of functionality in our data that we should always be keeping in mind, which brings us back to that user interface, which unfortunately often is a little bit lacking in terms of really bringing to bear human interpretable meanings. As one example, I have a few names here from the US Census Bureau, which on one hand is very highly systematic, encodes a lot of information about provenance, but there's nothing at all human interpretable about it. There's nothing that should tell me that P0130001 I can't intuit that that means median age. Or on the other hand, we can look at the Congressional Cooperative Election Study, which is a very popular political science survey in the United States that has very nice, friendly, human readable names. But again, they don't get at that functionality. For age, I don't know if that's a categorical bin or continuous. Has child versus own home. Those both sound similar, but they're formatted differently. So should that tell me something? I don't know. And for approval, was that a yes or no question? Is that on some sort of a ordinal scale? Without knowing all of these questions, there's no way I can start analyzing this data. And of course, it is in fact my responsibility as an analyst to do that sort of EDA and understand how all these variables work. But even once I've done that, it's a lot to keep in my head as I'm going through these results. And more importantly, it's not just about me. In any research or industry setting, we have countless data handoffs between data producers and data consumers. And often at different points in time, we're playing both of those roles. Whether we're a lab assistant handing data to a PI, whether we're collecting data in the field, and then just days later sitting down at our desk to analyze it, whether we're a primary author and asking a replicator to look at our data or seeking a code review, or finally, a data engineer and a data analyst sitting in completely separate parts of the business, doing their own thing. So, and this can often cause a lot of discord where the second person that receives the data set and looks at it thinks it's wrong and thinks they're data quality issues, when really it's just a misunderstanding and a lack of alignment in terms of the intent in that data. So one method that I found very helpful to address this issue is using controlled vocabularies to name columns and embed that sense of meaning in those performance contracts in column names. And controlled vocabularies are already a well-known concept in data management in order to encode specific fields by better defining those exact values that are allowed in certain fields to mitigate actually some of the challenges that we heard a lot about in the previous talk. But what I propose here is a little different, to use controlled vocabularies to actually name the columns themselves. So what this looks like is we can establish well-defined stubs at many different levels to encode different types of meaning and semantics. And then some of these stubs, as we'll see, can carry with them different types of performance contracts. And when composed together, they can really start to get at increasingly nuanced concepts. So let's see how this works with an example. And I'll caveat this with, this is just one example. I'm not married to any one specific definition of how to have a controlled vocabulary, so much as the fact that you probably should define the one that works the best in your own circumstance. So I personally think it's helpful to start with a type level. So I might start with stubs like ID, end, n, amount, val, and you can probably already intuit what some of those means. But the nice thing is you don't have to intuit them. After we define the stubs, each stub can come with its own very specific and clear semantic meaning. For example, for the case of an indicator variable, we can say that's a binary 0-1 indicator, where the rest of the name will explicitly be telling you that positive 1 condition, not the 0 condition. But beyond that, these semantics can also sometimes come with performance contracts. You might have noticed that end and bin carry similar semantics, but I might impose on my end stub a stricter condition, such as not only is it always 0 or 1, it also is never null. So I know that I can have different affordances and features of that data, such as I can take the mean of that column and get a trustworthy population proportion. So again, you can start to see not null, not summable, certain date formats, how all of this just pre-work and thinking about our data can help mitigate some of those challenges and better explain some of the features that we talked about before. And then we could think about subsequent levels, like an entity level, to better describe the different measures and concepts that we want to measure in our analysis, and push our thinking to actually better define what actually we are trying to measure and investigate. So I think one relevant example in this past year has certainly been thinking about collecting and sharing COVID data. So in our entity level, we could think about a situation where we want to share data on COVID cases in different US counties. So we might have stubs such as county, case, hospitalization. However, a lot of these concepts are actually a lot more ill-defined than first meets the eye. So the semantic layer gives us a chance to more crisply define those. For example, in the situation where we're thinking about case, we can define that very clearly as what kind of a case? Well, a test confirmed case. And reported by who? Reported when? And here we note that it's reported by the date of testing. And again, that's the sort of thing that makes a big difference when we go to do analysis. Making sure that our data is consistently lined up across all of the counties, but also from the fact that it changes the performance contracts or the consequences in our data. For example, defining these stubs allows us to highlight the consequence that because we're aligning the data by the date of testing instead of the date of reporting, that data may be delayed and may be continued to backload. So we maybe can't trust the very end and very tails of our data. And so forth and so on. You can imagine us defining subsequent levels of stubs in this sort of controlled vocabulary with additional prefixes and details like metro or HPSA, which is a healthcare professional shortage area, that modify county. For cases and hospitalizations, we might be comparing both actual and predicted values, etc. But as we go through our dictionary and define these sorts of stubs, we give ourselves really a rich language in which we can define a combinatorial explosion of different concepts that are all still very crisply defined in our mind as the data producer and in the minds of subsequent analysts. And as we've seen, this just simple approach can actually help better encode a lot of those different data challenges, data design choices, and functionalities that we saw previously. One that I've been using a lot in particular recently is being sure to avoid feature leakage when comparing pre-treatment and post-treatment data by tagging all my variables with pre and post and simply dropping out of my data set anything with post in the name. It's a nice safeguard. So in summary, some of the benefits of this approach is it really helps automate maintenance the burden for producers, reduce the cognitive load for data consumers, and add clarity for code reviewers. And to kind of illustrate how the benefits spread across these three groups, I want to show a few more examples of what you can do with these names. So one of the first things you can do is use them to help enable better data documentation. This is rather simple and rather trivial and rather implicit with the approach so far, hopefully, in that you can simply break apart all those stubs and make your data then inherently searchable and indexable, either in a data dictionary or simply by autocomplete by those different component parts. More exciting to me is what you can do in the space of data validation. And here I illustrate with the fabulous package Point Blank, which I highly recommend checking out. We've already defined those performance contracts in our stub names, but we want to be sure that they actually are valid, that our data actually does do the things we say it's doing. And one nice thing about Point Blank is it allows you to use dplyr select helpers to easily configure a broad range of checks in very parsimonious amount of code. So for example, we know that count variables should always be positive, but instead of specifying every single count variable in all of our tables, we can simply use the starts with n selector within the call vals greater than or equal to 0 function and automatically create that check for all variables starting with n at once. This also makes our validation code and validation scripts portable between projects to further drive that sort of consistency. I had to cut off the table here, but these simple lines of code in my example data actually generated over 36 checks with just very, very low effort. And then finally, we also have data wrangling, where the same trick of using dplyr select helpers can be incredibly helpful for wrangling in a programmatic way. So here I show us quickly taking the mean of all indicator variables to calculate proportions, or taking the sum of all actual variables to get our total counts of all of the truly realized values that we're interested in. And very briefly, I'll show this isn't simply an R thing, simply a dplyr thing, but this method can expand to other languages as well. For example, here's like somewhat some code accomplishing somewhat similar things with Python. It's slightly harder. There's no quite as native way to get that list of column names, so we can do it in a list comprehension. But still with pandas, you can pass in those names of variables and still kind of program against the names instead of listing out every specific column manually. However, in this case, you may have noticed one of the first drawbacks and pitfalls of this approach, which is that when we took the mean of an indicator variable, it's still called ind, even though it's not a 0 or 1. So we've unwittingly fallen into a situation where we started out with perfectly manicured data, and now we're lying to ourselves again. So fortunately, dplyr actually does have one nice way to handle this, where when you're programmatically applying those data transformations, you can actually also specify how that renaming should occur. However, as you can see, that's starting to get a little lengthy and a little manual. And what this illustrates more broadly is the pitfalls of this sort of approach. Contracts are great and can really help us work more efficiently and more accurately and obtain better results. However, the one thing that's worse than not having a contract is having a bad contract where we're lying to ourselves or the users of our data. And there are a lot of different stages that we can do that in. Whether we maintain a definition of our vocabulary that isn't consistent with the names we're actually using, whether our column names over time drift away from that vocabulary, whether we aren't fulfilling the performance contracts implied by our stubs, or if we just forget to communicate any of this work that we've done to users and they don't know about it to extract the most value from it. So to attempt to help solve some of these challenges in the rest of our time today, I'll talk briefly through two different approaches that I've seen depending on the size of your project and where your data lives, what environments you prefer to work with, that can help make the management and meta work that you've created for yourself when imposing a controlled vocabulary a little bit more efficient. So first, we'll talk through some examples of my work in progress R package called Convo, which helps us define and evaluate a controlled vocabulary and can be used with R with local data or data from something like accessed in a database through something like dbplyr. For larger scale data projects in which you're using a database, I'll also demonstrate how dbt can help bring some of these same programmatic functions to SQL warehousing to allow us to still template and test our code. So first, we'll talk through a few pieces of functionality in the Convo package. Convo first allows us to define our controlled vocabulary in a simple YAML file, in which we have one entry for every single stub. So we can specify things such as the stub name, the human readable description, those validation contracts, which are essentially point blank functions, and any of the renaming mappings that we want to use, like we saw earlier, that maybe if I take the mean of an indicator variable, I want the prefix of that to change to proportion. And with that, we can simply read that YAML file into R as a Convo object with the read Convo function. Next up, Convo can help us assess the quality of our vocabulary. And first you have to think, well, what makes the vocabulary high quality? And there are sort of two things I settled on as preliminary traits. First, every stub should only have one meaning, and every meaning should be associated only with one stub, or otherwise you're just going to interject confusion. So for the first case, we can imagine a trivial example where we accidentally use cat to represent both cat as in categorical variable and cat as in the animal. In a case like this, we can use the pivot convo function to return the indexes and of the levels in which every step in our vocabulary appears. So in this case, we can see easily that cat actually appears at two different levels, and think about if one of those should be replaced by some sort of different stub that would help be more distinct and clarify the difference between those two concepts. Now, the second challenge is a little bit trickier to only make sure there's only one stub to represent every single meaning, because meanings aren't well indexed, they aren't well defined, they aren't something we can just group by in our data set. But one heuristic I relied on while trying to solve this problem is that often we'll probably come up with similar but not quite the same names to represent the same variable different times. So for example, if I'm working with customer data, I might call their account the whole word, account abbreviated by ACCT, account maybe abbreviated ACNT. So Convo has a helper function to try to exploit this heuristic and just do basic hierarchical clustering on a string distance to help group like stub names together and maybe help you notice some of that duplicativeness in your data and remove it. Once you've settled on a vocabulary that you're happy with, we can then use that to actually evaluate our column names. So with the evaluate convo function, we can pass it both that convo object and a list of column names and get returned to us any of the discrepancies of variables that don't adhere to that naming convention. For example, in the first case, XYZ is not a valid type 1 stub in our dictionary. So that's highlighted to us as an unallowed entity. Of course, there are two reasons that could happen. First, maybe I made a typo when naming my variables, and XYZ isn't something that should be in a variable name, or I might have neglected to include that in my vocabulary. And as I've actually worked with my data, I've uncovered a concept that doesn't fit with any of the current names in the dictionary. So alternatively, we can use the compare convo function, which essentially implements all normal set operations like unions, intersects, set differences between two different convo objects to help us find new candidates that should possibly be included. So now very clearly here, we can consider if something like XYZ does need to be included in that vocabulary. Next up, Convo intentionally has good synergy with point blank. And by simply passing in that Convo object, you can automatically create the same sort of Convo or point blank agent that we saw previously and run those checks. Or if you can prefer, you can use your Convo object to generate a portable YAML file of the point blank checks that can again be used across projects, thanks to a lot of great underlying work in point blank. And finally, on the documentation front, Convo does just provide a couple of simple helper functions to break apart the different individual stubs in one's variable names to put them in a data dictionary. And optionally, you can try to create a definition of that variable for your data dictionary by composing the human readable parts of those stub names with the glue string. Or if you prefer, you can document that higher level of abstraction controlled vocabulary instead of the variable names themselves and get a data table as you see below, where we see the stub names, the human readable description, and also have the point blank checks translated into those human readable performance contracts. So that essentially finishes our survey of the Convo package, but I'll just very briefly touch on what we do if we want to move this sort of method further up our data pipeline, such as if we're using a data warehouse for a more kind of mature and complex project. And for that, I found dbt an excellent tool to bring more of the same programming best practices that we talk a lot about in Python and R, and have seen a lot in the presentations today, into SQL, which tends to be generally a lower featured language. So for example, SQL templating can help us make sure that we're using our feature names correctly by bringing this control flow into SQL. So example with Ginger here, we're able to add a for loop to a SQL script and generate many variables that represent different lags in our data with one line of code, so we're sure to not accidentally introduce a typo in just one of those variable names. Next up, we can also write custom macros with dbt and use those to enhance our SQL code. And I have a project on GitHub now that essentially creates all of the dplyr select helpers that I've talked so much about throughout today and allows you to use them in a SQL workflow. So we can still use prefixes like starts with, contains, matches to extract all column names from a table and use across to apply that transformation to many different variables. So relating that back to our contracts, if I know all of my n variables represent counts, and I want those all represented in my data as integers, I can simply extract all of those variables that start with n and apply that transformation. But the final benefit of dbt comes in its ability to let us unit test SQL code the same way we unit test functions in an R package. And you can imagine the one risk of doing this automated casting is I could be masking an error. If many steps earlier in my process, some of my n variables were actually changed in something that wasn't a count, I probably don't want to automatically cast them and hide that error. I want to find out what's going on. So we can also add in unit tests for our data. And for the staging data before we do that sort of test, we can add another check using these same using the same sort of select helpers that we saw before and ensure that the absolute difference between the raw variable and the variable cast as an integer is absolutely minuscule and trivial for all variables, again, that start with some that match one of our convo naming conventions. So once again, here you can see in my dbt test, which would run and prevent the actual data set from being created should it fail, I can express that higher level concept in a single line of code, but then apply it to all 12 or so of my variables that meet that condition at the same time. So hopefully those provide some helpful tools to implement this sort of methodology in your own work. And in closing, I believe that controlled vocabularies really can help bring in all of these user interface components back to our data sets if we do them carefully. Universal symbols like n and int, when used consistently across data sets in a project or even across projects, can really help eliminate that burden of understanding and remembering what every single individual variable means for users. As we saw with something as simple as autocomplete, this does help cluster and group like variables together. And finally, our performance contracts can carry along with them some of those warnings similar to aesthetics that prevent us from making mistakes in our data. So thank you very much. This is definitely something I've enjoyed spending a lot of time thinking about. And I'll just mention briefly, I have numerous posts on this on my blog, both on the conceptual side and about some of these different tools. And for both of the tools themselves, those are both still in highly experimental stages. And I really welcome anyone to try them out and kind of provide feedback on the future for Convo especially. I've left open on my website some kind of open design issues and different ways I can imagine going as a next step, and would definitely be really interested in hearing from others that have worked in more in different data domains than my own to help guide those decisions. Thank you.
Thanks, Emily. That was incredible as always. I am certainly going to have the students using Convo for the next paper. So if you're here, you're a student of mine, I hope you're taking notes. No, that was just incredible. Charlotte and I were both feeling very attacked by your comments at the start of the talk about floppy disks. Charlotte, did you want to attack back briefly? We might just have a minute or two of
I don't
questions.
feel attacked. I feel attacked by the fact that there are people who don't know what floppy disks are. But
no, I would like to clarify. I am solidly in the
yeah, I knew you were. I was just like, wow, to be old.
Yeah, thank you.
I saved my highly important Crayola art projects on floppy disks.
No, Charlotte, did you want to ask about the usability versus?
Yeah, sure. I just had a question. I think some of the column names you showed were lowercase and like very easily completable by something like RStudio, but I was curious about the trade-off of like encoding all that information in column names versus like having to type those columns and deal with the names. I know especially like I hate writing columns that are all caps. Like if I have to shift my column names, like I'm going to clean them immediately. So I was curious as to your thoughts on that.
Yeah, so I definitely don't have a specific course in race on case one way or the other. I think as of late, I've personally been working with a database that like returns all variable names in uppercase. So I've just like, I think that piece of it's just kind of like influenced by my personal like habits and circumstances. I do think you bring up a good just like general point though, that I do recognize this definitely tends to lead to much longer column names, which I know can be a pain to use, but I like the thing that I think comforts me about doing it is my goal is also to like reference the column names themselves as rarely as possible and just use the helpers as much as possible. So I think so far, at least I've found it a trade-off that's like fairly worth it and hopefully still does result in typing less, not more.
Yeah, I can definitely see like the benefits from it are far more than like, as opposed to being too lazy to type the names. And it makes total sense once you start showing SQL that like when you're typing SQL code, it's actually more annoying to like go to lowercase to type the column names. You want to be typing in all caps there.
Does anyone, one other question maybe if anyone wants to, otherwise we should. Emily, maybe you could just add some of the links and stuff into the Slack or something at some point. I'd be keen to have a look in more detail. But thanks so much for a wonderful presentation and incredible work as always.
Thank you. Thrilled to be here and really appreciate the chance to share.